Picture this. You're gazing out the window of a space station. The Earth hangs in the distance, a vibrant sphere against the backdrop of infinite blackness. You're surrounded by the silent majesty of the cosmos, a symphony of stars stretching out before you. It's awe-inspiring, humbling, and maybe a little lonely. We've conquered the challenges of sending humans into space, but what about the more intimate aspects of our existence? What happens when we bring human connection, human intimacy, into this extraordinary environment? Okay, let's talk physics. Physics is the fundamental science that explains how everything in the universe works, from the smallest particles to the largest galaxies. It's the study of matter, energy, and the forces that govern their interactions. But today, we're going to focus on a very specific aspect of physics: gravity. Here on Earth, we take gravity for granted. It's the invisible force that pulls us towards the center of the Earth, keeping our feet firmly planted on the ground. We don't even think about it as we go about our daily lives, walking, running, or even just sitting down. Gravity is always there, a constant, unchanging presence. It's the invisible force that keeps our feet on the ground and our coffee in its mug. Imagine trying to pour a cup of coffee without gravity. The liquid would float out of the pot and you'd be left chasing droplets around the room. Gravity makes life on Earth predictable and manageable. But in the microgravity of space, all bets are off. Microgravity is a condition in which objects appear to be weightless and can float freely. It's not that there's no gravity in space, it's just that the effects are much weaker. This creates a unique environment where the rules of physics as we know them on Earth don't always apply. Remember those physics experiments with colliding spheres? In space, these experiments take on a whole new level of complexity. Without gravity to pull objects down, they move in straight lines until they collide with something else. This can make even simple tasks incredibly challenging. That's what trying to move in space can feel like. Every action has an equal and opposite reaction, as Newton's third law of motion tells us. So when an astronaut pushes off a wall to move forward, the wall pushes back, sending them floating in the opposite direction. It's a constant dance of motion and counter-motion. Now imagine trying to get physically close to someone in that environment. The lack of gravity means there's no stable ground to stand on, no way to anchor yourself. Every movement has to be carefully controlled to avoid drifting away. It's like trying to embrace someone while floating in a pool, but with even less resistance. Even a simple hug could turn into an unintentional game of cosmic dodgeball. Without gravity to hold you together, the slightest push or pull can send you spinning in different directions. It requires a level of coordination and awareness that we rarely need on Earth. Every touch, every movement, takes on a whole new dimension. The sensation of touch is different when there's no gravity to provide resistance. A gentle touch can feel like a push, and a firm grip can be hard to maintain. It's a delicate balance that requires practice and patience. You'd need the spatial awareness of a seasoned astronaut just to navigate a first kiss. In space, intimacy is redefined. It's not just about physical closeness, but also about understanding and adapting to a completely different set of physical laws. It's a reminder that even in the vastness of space, human connection finds a way to thrive. We humans are beautifully adapted to life on Earth, but space? Space throws us a whole new set of challenges. Our bodies, finely tuned by gravity, react in fascinating ways. Fluids shift upwards, giving you that puffy-faced, bird-legged look. And let's not forget about the cardiovascular system. Without gravity pulling blood downwards, the heart has to work overtime. Now imagine the complexities this introduces to, shall we say, more intimate activities. Blood flow, hormonal changes, even the basic mechanics of the human body. They're all affected by microgravity. We're talking about a whole new ballgame, folks. Chapter 3. Space Romance, a Technological Challenge. So, how do we overcome these cosmic obstacles? Well, leave it to the brilliant minds of science to come up with some truly innovative solutions. We're talking specialized suits, designed to keep couples in close proximity, almost like a personalized portable atmosphere. And then there's the concept of inflatable modules, creating a cozy, controlled environment within the spacecraft. It sounds like something straight out of science fiction, right? But the reality is, we're already exploring these possibilities, because when it comes to pushing the boundaries of human experience, even space is no limit. Chapter 4. Cosmic Conundrums, Ethics, and the Future of Humanity. But space exploration isn't just about overcoming physical challenges, it's about grappling with profound ethical questions. As we push the boundaries of human presence beyond Earth, we are faced with dilemmas that test our moral compass. These questions are not just theoretical, they have practical implications for the future of humanity. Space is a high-risk environment. The vacuum of space, cosmic radiation, and the sheer distance from Earth create a setting where the stakes are incredibly high. Every decision made in space can have life or death consequences. This makes the ethical considerations even more critical. Every activity, even something as seemingly simple as physical intimacy, carries potential dangers. The microgravity environment affects the human body in ways we are still trying to understand. For instance, muscle atrophy and bone density loss are well-documented issues. But what about the psychological and emotional aspects of human interaction in such an isolated and confined space? And then there's the question of reproduction. The idea of conceiving and bearing a child in space brings up a host of ethical and medical concerns. How would pregnancy progress in microgravity? Would the fetus develop normally? These are questions that we must consider seriously. What happens if a pregnancy occurs in space? The lack of gravity could affect everything from the mother's circulation to the baby's growth. We have no precedent for this, and the unknowns are daunting. Medical emergencies in space are already complex. Adding pregnancy to the mix would require unprecedented preparation and innovation. How does microgravity affect fetal development? Studies on animals have shown that microgravity can impact cellular processes and organ development, but humans are far more complex. The ethical implications of experimenting with human reproduction in space are profound. We must weigh the potential benefits against the risks and moral considerations. These aren't just hypothetical questions, they're very real concerns that we need to address as we venture further into the cosmos. As we plan for long-term missions to Mars and beyond, these ethical dilemmas will become increasingly urgent. We must develop guidelines and protocols to ensure the safety and well-being of all space travelers. The future of humanity in space might very well depend on our ability to unravel these mysteries. Our success in addressing these ethical challenges will determine not only our survival, but also the kind of society we build as we expand into the final frontier. The choices we make today will shape the destiny of generations to come. Outro, the final frontier, love among the stars? So, can you have sex in space? This question, often asked with a mix of curiosity and humor, actually delves into some of the most profound aspects of human existence. It's not just about the act itself, but about the very nature of human connection and survival in the most extreme environments. The answer, my friends, is far more complex than a simple yes or no. In the zero-gravity environment of space, our bodies behave in ways that are still not fully understood. The lack of gravity affects everything from blood flow to muscle function, and yes, even the mechanics of intimacy. It's a question that pushes the boundaries of science, technology, and our understanding of human nature. Scientists and engineers are constantly working to understand how the human body adapts to space, and this includes the intimate aspects of human relationships. The challenges are numerous, from the physical to the psychological. Perhaps one day, we'll have all the answers. As we continue to explore the cosmos, we may find solutions to these challenges. We might develop new technologies that make it easier for humans to live and love in space. Imagine a future where space stations are equipped with special habitats designed for comfort and intimacy. Perhaps we'll see the birth of the first spacefaring generation, humans born under a canopy of stars. This idea, once the stuff of science fiction, is becoming increasingly plausible. With advancements in space travel and habitation, the dream of raising families in space could become a reality. But until then, the cosmos continues to beckon, a vast and mysterious frontier ripe for exploration, full of questions waiting to be answered. Each mission, each discovery, brings us one step closer to understanding our place in the universe and how we might thrive in it. Are we ready to take that giant leap, not just for humankind but for love itself? The journey to the stars is not just a scientific endeavor, but a deeply human one. It challenges us to think about what it means to be human, to connect and to love, even in the most extraordinary circumstances.